Hello everyone, this is Mrs. Snook with section 3.6, which is non-linear models. You're going to need to print out or have on your screen with you a copy of the 3.6 notes handout, and you can find that on Canvas. You also need to have your calculator. First thing we're going to do is classify scatter plots. And then we're going to use scatter plots in a graphing utility to find models for the data in the scatter plot. And we're going to not only find the models, we're going to be able to do that with using exponential, logarithmic, and power models. We're going to have 3 different kinds of regressions we're doing today. First thing, let's classify some scatter plots. So take a look at this first one right here. It's number 1 scatter plot. That one is shaped like a logarithm. So this one you would use for a logarithmic regression. Now look at the second scatter plot. This one is shaped like an exponential function, so we would use an exponential regression on this one. Third one, that looks like a line. So remember back in chapter 1, we did linear regression. And then in chapter 2, we did this one, which is a quadratic. As you can see, you've got a parabola through here. So next on your handout is detailed instructions on how to do first exponential regression. So here's some data. Here's what the stat plot would look like. And then here is going through the regression. And then right here is when you use zoom stat to see the graph. I've also put together the same thing for logarithmic regressions. Enter your data. If your scatter plot looks like this, it's a logarithmic regression. And then on the calculator, it wants you to use ln reg, so that's natural log. And again, zoom stat to see what it looks like. The last one we haven't talked about much. It's a power regression, and that's where you have y equals a times x to the b. So we're going to figure out what this coefficient is here, and we figure out what the exponent is. Works just like the others. You put in your data, look at your scatter plot. This time you're going to do power regression, PWR-REG, which is A on your calculator. And again, zoom stat, and you'll see what it looks like. So what I want to do here is want to do all 3 regressions. So we're going to do an exponential, we're going to do a logarithmic, and we're going to do a power. This is like what you would see on your test. So you're going to get one set of data. We're going to do all 3 of these regressions. And then we're going to compare the R-squared for the models and decide which one is your best fit. So first thing we're going to do is put our data in. So you're going to go Stat, Edit. If you have anything in here, you'll want to clear it out first. I've already entered the data, so I'm just going to leave it like this. And the first thing it asks us for is a logarithmic regression. So we're going to do logarithmic. I'm writing logarithmic just to label which regression it is. I'm going to press Stat, Calc, and I'm going down to number 9, where it says ln reg, because that's your natural log regression. Press enter. Now mine, L1 and L2 are populated for me. I'm going to come down to store reg EQ, and I'm going to put this in y1. So vars, y-vars, function, y1, and then I'm going to come down here, I'm going to say calculate, and there it did it for me. So y equals, this is going to be a plus b natural log of x. A is 4448.325. So that's a plus natural log, whoops, forgot my b, plus 937.491. 937.491 natural log of x. So that's our logarithmic regression. The next part says to find and compare coefficients of determination. So I'm just going to say logarithmic. The r squared we got is right here, 0.85. Now that's less than 0.9. So we know right away that is not a good fit. So I'm just going to put a little red X there. So I know that's not a good fit. All right, the next one it asks you for is exponential. So we're going to do our exponential model. And before we do that, let's go ahead and take a look at this graph. So the red squares are our data. The blue is the logarithmic regression. All right, let's do the exponential regression, and then we'll check the graph again. So I'm going to go to Stat, Calc. This time I'm going to exponential regression. That's 0, expreg. Press Enter. And this time I'm going to store this one in y2. So vars, y-vars, function, I'm going to come down to y2. And then I'm going to calculate. All right, so this is going to be a times b to the x. So y here is a, 4,893, 4893.311 times b, which is 1.036, and we're going to raise that to the x, which on our variable is t. So that's our regression for that one. And then I'm going to put down the r squared for the exponential regression. And the r squared here is 0.97. Well, let's say r squared. So that's looking pretty good. That one's a contender for being our best model. All right, let's find out for sure. Oh, I forgot. Let's take a look at the graph. So there we have the red line. That is our exponential regression. And I think I'm going to see if I can change the color on this because we're already using red. Black. Let's use magenta. Oops, I didn't save it. Yeah, always make sure you save it. So I'm going to say OK. And now let's look at our graph. All right, so the magenta one, that's our exponential regression, and we can tell just by looking at the graph that it is way better than the logarithmic. All right, last one we're going to do is power. And I'm going to go ahead and, yeah, black will be fine for y3. So we're going to go to Stat, Calc. This time we're doing a power regression, so we're going to scroll down till we get to power regression. One more. There, power reg. PWR-REG, and that's A. Hit Enter. My lists are populated for me. Let's put this in y3. So I'm going to go to vars, yvars, function y3. And we're going to calculate that. All right, so this one is a times x to the b. And in our problem, we're using t. So a is 4,609.901. 4,609.901. And we're going to multiply that times t, and we're going to raise that to b, which is 0.157. And then the r squared for our power regression is 0.877. Okay, let's take a look at that graph. And you see that that black line? It's like on top. It kind of overlaps a little bit with our logarithmic regression. And you see it also is a 0.877. That's below 0.9. So I know right away that's not it. And also the 0.97, that one's the closest to 1. So the model of best fit is going to be our exponential model. All right, that's it for today's lesson. Thank you for watching and have a great day.